Let's say you're building a game and have a large art asset pack with many different character skins. You set up an animator with rules for when and how to play 8-directional animations. Now you want to apply the same logic to all the other skins. Since the animator rules are identical, play in a specific frame based on which of the 8 directions the object is moving, we don't want to recreate the animator for each skin manually. In this Unity 2D game development tutorial, we'll learn how to save time by giving a game object with a complex animation rule set multiple skins, and how to reuse the same animator logic for each one with Animator Override Controllers. I've always enjoyed playing tower defense games, and I've also loved placing roads in the classic SimCity. Watching traffic automatically flow through the roads made it feel alive. If you're working on a tower defense game, a traffic control or a racing game, or even a cozy city building simulator, this class will cover the essentials you need to know. I do have some ideas how to expand this later. This course is designed for complete beginners, though I do expect you've built at least one small project in Unity before. If you find value in my classes, don't forget to click the like button. You can code along with me from the beginning, or you can go to a source code checkpoint, download the project at that stage and continue from there. It's up to you. I create a new blank project with Universal 2D Render Pipeline. I'm using Unity 6, but you can use any Unity version you want, it doesn't matter. In Assets Scenes, I rename my scene to Game. Inside the Assets folder, I create a new folder I call Art. You can download all art assets in the resources section below. I'll start with this simple sprite sheet, where I have one frame representing an enemy and another frame representing a point along a path. With the image asset selected, inside the Inspector tab, if you're using pixel art like this image, you want to make sure it's not blurry. So we set filter mode to point no filter and compression to none. I click Apply, I open the sprite editor, and slice, grid by cell size. These frames are 100 × 100 pixels. I click Slice, then Apply. Now I can use this little arrow to expand the sprite sheet and see individual frames. Here in the hierarchy window, I see all the game objects that make up my game scene. I can right-click and create an empty game object. I call it Path. Every game object in Unity has a transform component, which defines the object's position, rotation, and scale. We can use these tools here. For example, I can select the Move tool to move the object around the scene. And when I do that, its position values change. I can also right-click and reset transform to center the object in the middle at coordinates 0, 0. So this is the game scene. This white rectangle represents the visible game area. If I open the Game tab, this is what the game will actually look like when played. You can sign up for my newsletter, where I share bonus content packs that you can download for free and use in the games we make. In my art folder, I can expand my sprite sheet. If I drag and drop this frame into the scene, Unity will automatically create a game object for it. Unity will also automatically detect that this game object has an image. So on top of its transform component, it will also give it a sprite renderer component, where we can do many things to handle and adjust the image. I will rename the game object to Waypoint. With the Waypoint game object selected, I can use the Move tool to move it around the scene. Doing that will update its X and Y position. I can also set the object's position manually by changing these values here. On the Game tab, this is what our game looks like so far. I'll change the aspect ratio to Full HD for better rendering, and I'll zoom out using this scale slider. I like to keep my small game preview down here. Now, when I make changes to the scene, I can instantly see how those changes affect the playable version of my game. Now that we understand the basic Unity layout, let's build something more interesting. Inside my Assets folder, I create a new folder I call Prefabs. I can drag and drop my Waypoint game object into this Prefabs folder, turning it into a reusable game asset. Prefabs are pre-configured, prefabricated game objects. Let's say I have a game object like this Waypoint, and I configured it in a specific way. Now I want multiple of these game objects, all configured the same way. Instead of repeating the process over and over, configuring them one by one, I turn it into a prefab and I can duplicate it as many times as I want. Notice that after turning it into a prefab, it changed color. I can delete it from the scene now, and I can just drag in as many as I need. If I want to make change to all of these copies, I can just change the main prefab in assets, and it will update all of them. I delete these, and I leave just one for now. GameObjects in Unity have components that give them special functionalities. Unity has many components we can add, and we can also create completely custom script components to write custom logic. So let's say I want to write a simple script that connects all of our waypoints with a line, and I want enemies to move and follow along that path. Inside Assets, I create a scripts folder. In Unity, we use the C# programming language. Let me show you how much you can achieve with just a few simple lines of code. Inside the scripts folder, I right-click, create, and I choose a monobehavior script. I call it path. Be careful here, you can't just rename this file later, because Unity will use that name to define the class inside the file. So make sure the name of your file and the auto-generated class name inside it match. I select the path GameObject, and I attach the path script as a custom component, like this. I double-click the script file, and Unity opens it in my default code editor. If you've never heard of monobehavior before, all you need to know is that it's a special Unity class that allows us to take scripts and attach them to GameObjects as components, just like we did, and make the code inside that script interact with that GameObject and with others in the scene. Monobehavior is a fundamental building block of Unity. You'll see it all the time. Monobehavior also gives us access to so-called lifecycle methods, useful code blocks where we can put our code depending on when we want that code to run. You can also see that Unity created two most important methods. Inside the start method, we can put code we want to run only once at the beginning, and the update method is where we put code we want to run over and over. There are many more built-in lifecycle methods, and we will use some later on. For now, to keep this clean, I will delete them and I will just declare a variable. We are inside a custom path class we created. I want a variable that will hold an array of waypoints so that we can connect them together and send enemies along that path. In C#, we define variable this way. We start with an access modifier. If the variable is public, then everyone can see it. Or if it's private, it's accessible only from this script. I need my waypoints to be available from other scripts, so I set the access modifier to public. The second word defines the type of value this variable will store. In this case, it will hold an array of prefabs. Each waypoint is a prefab, and prefab is a GameObject. Square brackets mean it will be an array of GameObjects. And the last part is whatever I want the variable to be called. So, who can access this variable, what data type it holds, and what name we give it. In C#, we define all variables like this. If I save changes and go back to Unity, on the path GameObject, inside its custom script component here, I see that waypoints variable. It's an array, so I can click plus to add elements to it. Because of the variable type we defined, you can see these fields expect a value that is of GameObject type. I go to the prefabs folder, and here we have a waypoint prefab, a pre-configured, prefabricated GameObject. I will need 5 of them in total, so I drag them one by one into the scene until I have 5 copies. I select the path GameObject again, and I will drag this first waypoint into the first field in the array, like this. Waypoint 1 GameObject into this field, and I do the rest. Ideally in the same order, so we have an increasing sequence of numbers that matches the order in the array. This icon is to show and hide gizmos. In Unity, gizmos are visuals that appear in the scene view, but not in the game view. We will use gizmo lines to visualize our path connecting the waypoints, and then we will make enemies move along that path. So let's make sure we have gizmos enabled, and let's open our path script. Unity has a built-in method called onDrawGizmos that we can use to draw visuals in the scene view to help us design or debug our game. If this waypoint array has some elements in it, if the length is more than 0, I create a for loop that will cycle over all the elements in the array. We set the color to gray, and for each of these waypoints inside the waypoints array, we will draw a line connecting them. Unity has a built-in gizmos drawLine method that takes the start point and end point, and it will draw a line between these two positions. So I want to start the line at the position of the game object at this index. I access its transform position, and I want to end the line at the position of the next waypoint, so index +1. As we cycle over the array, this index value is increasing by 1, and we are drawing lines between the waypoints. When we reach the last index in the array, there will be no index +1 anymore, so that would give us an error. So I only want to draw these lines until we reach the second to last element. Only draw the lines between this and the next index if the index is the length of the waypoints array -1. Let's save that. You can see a line connecting all our waypoints. Now I can select individual waypoints, and I can use the Move tool to modify my path in any way I want. Maybe I will have some tilemap behind, and I will make sure this path matches a road in the artwork that I want the enemies to follow. Notice that because the line is drawn using gizmos, it's visible only in the scene view, but it doesn't render in the game view, which is exactly what we want. I left-click the first waypoint, and I shift-click the last one, selecting all the game objects in between. I will parent all of them under the path game object to keep the hierarchy organized. I can also rename this to path 1, because we can create multiple different ones in our game later if we want to. With path 1 selected, I use the Move tool, and I can also move the entire path now, like this. I can select individual waypoints to modify them in any way I need. This technique is extremely useful for tower defense games, racing games, as well as something like MOBAs, such as League of Legends, where you have NPC minions moving automatically along the lanes. You can use the same exact technique we have here for a 3D game as well. Maybe I also want to give the waypoints some labels, so I can easily see at a glance which waypoint corresponds to which game object. Inside onDraw gizmos, I can do that here. If we want to define styles for our text in Unity, we can use the built-in GUI style class. GUI stands for Graphical User Interface, and we can use this class to define visual styles, fonts, colors, alignment, and so on. Now I can take that style and I set its normal text color to white. And most importantly, I set alignment to middle center because I want the text to be horizontally centered around each waypoint. I can draw text using handles built in Unity class. We need to include the Unity editor namespace up here to be able to use handles. Handles.label will let us draw a label in the scene view. We pass it 3 parameters. Where we want this label to be drawn, I want it at the position of the waypoint it belongs to, plus 0.7 units above it. The second parameter is what we want the label to say. I will make it display the name of the game object. We can see the names in this field here. And finally, as the third parameter, I apply our custom style we just created. If I save that, you can see we have little labels above each waypoint. In the game view, none of this will be visible. Perfect. Now, let's bring in some enemies and make them walk along this path. Inside Assets Art, I have my sprite sheet, and one of the frames is this simple enemy silhouette. I drag and drop this frame into the scene, and I rename it to Enemy. We can replace it with animated characters later, but first, let's focus on the pathfinding logic. I go to Assets Scripts and create a new folder I call Enemy. Inside, I create a new monobehavior script. I will also call it Enemy. With the Enemy game object selected here, I drag and drop the Enemy script here as a custom component. I open the script, I delete all this code, and I will define a variable here. I start with serialize field in square brackets like this, and private. The type will be float, which is a decimal number, a number with a fraction part. I will call my variable move speed. I will also give it a default value, for example 3f, f for float. We know we have public variables which are accessible from other scripts, and they are also displayed here in the Unity inspector. Private variables are accessible only from the script, and they don't show up here in the inspector. If I want a private variable, but I want it to display in the inspector, I give it the serialized field attribute, like this. So if I save my changes and I go back to Unity, I can see move speed here, like this, and we see the default value of 3 I gave it. I want another private variable. This time I don't need to see it here in the inspector, so I don't use serialized field. The type is vector3, and I call it target position. Vector3 is a data type that has 3 components. We use it for position, for example, because position needs x, y, and z values. In terms of naming conventions, look at the custom names I'm giving these variables. We will follow .NET style naming conventions here. Public variable names are spelled in Pascal case, where the first letter is capitalized. Private variables will be camel case with an underscore prefix. And my personal choice is that serialized field variable names will be spelled like this, so that Unity can turn them into names that are nice to read in the inspector. These are just conventions. If you don't follow these rules, it will not break your code. But people use them because you can see at a glance what is a public and private variable. Inside the update method, which runs over and over, we want the enemy to move towards the target position. We learned about start and update lifecycle methods. There are many more. For example, we have the onEnable method, which runs every time a GameObject is activated. Inside, we'll put all the code that I want to run when I reuse this object, because later on, we will learn how to optimize our code for better performance by turning enemies into reusable objects. And every time we reuse the object, every time we activate it, code inside onEnable method will run. When the enemy gets activated, we will give it some target position. For example, just as a test, let's give it a new vector3 and set the position to 4, 0, 0, x, y, z. As the update method runs over and over, I want the enemy to move towards that target position. So I set the enemy's transform position to a built-in move towards method. This method expects 3 parameters: current position, target position, and move speed. So I pass it the enemy's current position, where it is right now, and its target position, where I want the enemy to move, and how fast it will move there, which will depend on the move speed property from line 5. I multiply it by time.deltaTime. Delta time gives us the time in seconds that passed between each call of update. If I account for the actual time passing by like this, we make sure that the enemy moves at a consistent speed on all devices. It's important because the update method might run faster on a more powerful device, but we don't want the device's ability to serve more frames per second to affect how fast things are happening in our game. Accounting for delta time is a very important technique that ensures the speed at which game events happen depends on actual time and not on the frame rate. This is one of the fundamentals of game development and something we have to always make sure we do. Okay, so we have the enemy, a target position of 4, 0, 0. Let's save that and play to see if it worked. We can enter play mode by pressing this play button up here. As you can see, the enemy is moving from wherever it is to the target position of 4, 0, 0 at the speed of 3 units per second. This is position 0, and these little squares are units. The horizontal x position of +4 is 4 units to the right from the middle. 1, 2, 3, 4. I exit play mode. We know our code works. So now, instead of making the enemy move to a position like that, I want the enemy to move from waypoint to waypoint following a path. I select my path 1 game object and I open the path script. To move along the path from waypoint to waypoint, we need a method that will give us the position of a waypoint, depending on an index in the waypoints array. When I call it and I ask what is the position of the element at index 1 in the waypoints array, I want this method to give me x, y, and z position of wherever in the scene we placed this waypoint object. Indexes start from 0, so 0, 1, 2, 3, 4. So this method will expect a parameter of integer type, a number without decimals. I call it index, and it will return the waypoint array at that index we passed to it. It will give us the transform position of that waypoint at that index. So whenever I need to know where to move next, I will call this public getPosition method. To access that getPosition method we just defined from the enemy script, I need a reference to the path1 GameObject and to its path script component, which contains that method. So serialize field, private, type is path, because I want this variable to hold a reference to this custom path component. And I will call it, for example, current path. Now it's time to learn about another lifecycle method called awake. This method runs once when the script instance is first loaded, same as start, but it runs before onEnable and before start. Inside awake, I take current path and I need to point it from the enemy GameObject to this path1 GameObject. And on it, I need to find this path component. There are multiple ways to do that. For example, I call the built-in find method and I pass it the name of the GameObject I'm looking for. I need to make sure the spelling matches the name of the object I'm looking for exactly. From it, I call getComponent because I'm looking for this path component here. So now, the current path variable holds a reference to this component. We need it because that component has this public getPosition method that we will want to call from the enemy script. Inside onEnable, I set target position to current path, this component, .getPosition, and I pass it index. And depending on the index value I pass it, it will give me the position of one of these waypoints, 0, 1, 2, 3, 4. For example, if I pass it index 3, it would give me the position of this waypoint GameObject. The reason I had to use awake here is the order of execution. onEnable runs before start, so I couldn't put this line inside start. I had to put it inside awake, because awake runs before onEnable, and I needed this reference to be ready at the point when enable runs. Don't worry about this too much, it will become easy to keep track of the more you work in Unity. You can always have a copy of this chart somewhere and check it when you need it. So if I set this to index 3, I go back to Unity, and I expect enemy will walk from wherever it is right now to the position of this waypoint. I enter play mode and yes, that worked perfect. Let's try to set index to 0. Save. I expect the enemy to walk to this waypoint. Play mode. Great. We have most of the logic. All I need to do now is to make sure the enemy increases target index by 1 every time it reaches its target position, and that will make it move along the path we defined here. So let's define a private integer I call current waypoint. It will be 0 or 1 or 2, 3 or 4 as the enemy moves along the path and changes targets. Every time we activate or reactivate this enemy, set its target position to be the first waypoint on the path, index 0. As the game runs, we check when the target position was reached and we set a new target position. We need to know the relative distance, how far is the enemy from the target position, the difference between the enemy's current position and its target position. The enemy can be to the right or to the left, so the value can be negative or positive, but we want to disregard that plus or minus. We only want the distance between these two positions. We don't care about the direction. That's why I want the magnitude of the vector. If the enemy is close enough to the waypoint, to its target position, let's say if the distance is less than 0.1 units, we increase the current waypoint value by 1. And we set the enemy's target position to the next waypoint in the path, like this. The enemy will move towards that next target position, and again, when it's close enough to it, it will increase the index again to move towards the next waypoint. I save and play to see if it works. The enemy is moving towards one waypoint after another, following the path we defined. When it reaches the last waypoint, we get an error, so let's fix that. Only increase the current waypoint by 1 if we are at an index at least 1 less than the length of the array. Else, we know the enemy reached the end of the path, so we will deactivate the enemy. We set active to false, like this. I save and play. The enemy follows the path, and when it reaches the end, it gets destroyed, it gets grayed out and deactivated. I create an empty game object and I call it spawner. I want to create a game object that will spawn enemies at a specific interval. In the game later, it can be a cave that orcs are coming from or something like that. I reset transform just to make these numbers nicer. No real reason for this otherwise. Inside the assets scripts folder, I create a new monobehavior script I call spawner. Spawner game object selected here, and I attach spawner script as a custom component. I delete all this code, and I define a private float spawn timer and spawn interval. I set it to 1 second by default. Spawn timer will count from 1 second down to 0. It will spawn an enemy and it will count again. So as the update method runs over and over, we are reducing the value of spawn timer by delta time, by real time that is passing by between updates. When spawn timer is less than or equal to 0, we set spawn timer back to spawn interval, which is 1 second right now, and we spawn an enemy. This method doesn't exist yet, so let's write it. Private void spawn enemy. Inside, I create a temporary helper variable. Type will be GameObject, and I call it spawned object. To create a copy of a GameObject from a prefab with code, we call the built-in instantiate method. And we pass it the prefab we want to create a copy of. This prefab variable doesn't exist yet, so let's define it. Public GameObject type, I call prefab, like this. Pascal case, because this is a public variable, so I have to change the spelling here as well. Notice I'm keeping everything generic so that I can set this prefab to be enemy or any other prefab object we will have in the game later, so we can use this spawner class to spawn pretty much anything. It can be very useful. Once we create spawned object from a prefab, we take it and we set its transform position to be the same as transform position of the game object this script is attached to, so the position of spawner game object. Wherever I place this spawner in the scene, that's where game objects will be spawning from. So now I have this prefab field, and whatever prefab I put there, that's what this spawner will start producing copies of. Save that, and in Unity, I see that prefab field here. I go to Assets, Prefabs, and I drag and drop enemy game object in here, turning it into a prefab. I can reset its transform to keep this cleaner. I delete the enemy game object from the scene. Spawner selected, and I drag the enemy prefab into this prefab field. I enter play mode, and enemies start spawning. They start from wherever I placed my spawner game object. They move towards the first waypoint in the path, and they follow the path. When they reach the end of the path, they get deactivated and grayed out here in the hierarchy. As you can see, we keep creating new enemies and deactivating the old enemies. I can also destroy the old enemy game objects completely, but for performance reasons, we want to reuse them instead. So instead of constantly creating and destroying enemy game objects, we want to create a pool of, let's say, 10 enemy game objects. We activate them when we need them, and we deactivate them, returning them back to the object pool instead of destroying them. Object pooling improves performance by reusing inactive objects instead of repeatedly creating and destroying them, which reduces memory allocation and garbage collection overhead. Let me show you a quick and simple object pool logic I like to use for my games. Inside assets scripts, I create a new monobehavior script I call object pooler. Let's open it. Inside, I delete all this code. I define a private variable I call prefab, what kind of game object we want to store in this pool. For example, this would be the enemy prefab. We will also need pool size, how many of these prefabs we want to pre-instantiate. We want to fill this pool with inactive game objects and activate them when we need them. I will give it a default value of 5, but we can change that later. I will also need a data structure to hold them, private list of game objects. I call, for example, pool. To be able to use list, we need system collections generic namespace up here. Inside the start method, I will create the pool. I assign the pool to a new empty list of game objects first. Then I write a for loop that will cycle over the pool, 5 times in this case. And it will create new game object 5 times. Let's define that method here. Private method that will return a game object. I call it create new object. Helper variable of game object type we call obj. And we already know that to create a game object, we just call the built-in instantiate method and we pass it the prefab we want to create a copy of. After we create it, we set active to false. We are just preparing some inactive objects into the pool here. We take pool from line 8, we add this new inactive object inside, and we make this method return that object. Let's save that. In Unity, I create a new empty game object I call enemy pool. I reset its transform. Again, our object pooler class is generic, so we can reuse this script to create different object pools in our game. Enemy pool selected, and I attach object pooler script as a component. Prefab field expects a game object that this pool will consist of. I go to Assets Prefabs, and I drag the enemy prefab into this field. The initial pool size is 5 by default, but I can change it if I want to. If I enter play mode, our script automatically creates 5 inactive enemy game objects, but they are all on the top level in hierarchy. I exit play mode. I would prefer if the pooled objects were parented under the enemy pool. In my script, I can pass instantiate an optional second argument that defines a parent. So I pass it transform, but it refers to the game object this script is attached to, in this case enemy pool. So I'm saying set enemy pool as the parent and nest these game objects under it. Inside spawner, I comment out spawn enemy for a while. Save that. Now if I play, start method runs and it creates 5 inactive enemy game objects and it puts them under enemy pool like this, keeping the hierarchy clean. The idea behind object pooling is that when I need a new enemy, I activate one of these, and when I destroy the enemy in-game, I just deactivate it, putting it back into this pool of available objects. Doing this is good for performance, mainly because of automatic garbage collection and memory allocation processes, which can cause our game to slow down if we are constantly creating and destroying new game objects. Object pooler will need one more thing, a method that will give us one of these inactive game objects when we need it. I will run a for each loop, which will iterate over all game objects in the object pool. We have that pool here on line 8, and as we just saw, it will hold 5 inactive enemy objects. For each loop, we'll check objects in the pool one by one, and when it finds the first inactive one, if active self is false, exclamation mark means false, it will return it, giving us the game object. We are creating 5 game objects initially. Maybe we are in a situation when all of them are being used, and this method will not find any inactive one. In that case, we just create one more and we return it. If needed, we increase the size of the pool, like this. So now, whenever we need a new game object in the spawner, instead of creating a new one, we will call this public getPooledObject method. Inside spawner script, we will not be creating any new game objects here, so I can delete this line. When we spawn an enemy, we want to take the object pool and take one of those inactive game objects in there. I comment this out for a second. I create a variable, type is object pooler, and I call it pool. What is the object pool this spawner will be spawning enemies from? Save that. In Unity, we see that pool field here. And I want to be spawning from this enemy pool. So I drag the game object in here. From it, I can call this getPooledObject method to get one of the enemies from the pool. So when I want to spawn a new enemy, I take the object pool, which we know will be enemy pool in this scene, and we call its public getPooledObject method, which will either give us one of the available game objects, and if there are none available, it will create a new one. Then we do what we did before. We position it wherever in the scene the spawner is, and we activate it. If you remember, when the enemy reaches the last waypoint, it will get deactivated, which will return it back to the pool of available objects. I will also uncomment spawn enemy here. Now if I save changes, spawner selected, move tool, and I will move it somewhere around here. I play, and enemies start coming from the spawner to the first waypoint, and then they will follow from waypoint to waypoint along the path. Notice that if I need more, Object Pooler script will create more, and at some point we have enough, and we will start reusing the old enemy objects. Now we are reusing the same 11 enemy game objects over and over. So this will be the base project, and I created a GitHub repository for the game at this stage of development. This is the URL. I will also link it somewhere in the resources down below. It's a complete Unity project with all the scripts, art assets, and it might be useful if you get stuck to compare your code to mine. If you want to open this project in Unity, you can download a zip file here. I unpack it somewhere on my computer where I keep my Unity projects. I open Unity Hub, I click Add, and Add Project from Disk. In a pop-up window, I find the place where I unzipped the GitHub files, and when I add it, it will appear here. When you open it, Unity will take some time to install all the necessary packages, and one confusing thing is that it might open the project like this, where all you see is just this untitled scene. If you see just the untitled scene like this, let me know in the comments. I'm not sure if this happens every time or only for some people. Anyway, all I have to do here is to go to Assets, Scenes, and I open one of the game scenes. And that's it. You have the same Unity project as me. We have a path. Let's turn it into a road and then make cars follow along. I go to this URL. All the art assets we're going to download from a third-party site should be free. If they are no longer available for free in the future, there will be an alternative resource available in the video description, so you can still follow along with the tutorial. If you want to support the artist, you can pay here, but you can also just click no thanks, just take me to the downloads. Let's download it. This pack will give us a PNG file with road tiles. I rename the file to roads, and I drag and drop it into the assets art folder. It's pixel art, so I want to set filter mode to point no filter, and compression to none. For pixels per unit, we check the tile size on the sprite sheet. The author says it's 64 × 64, and we want 1 tile per unit, so we set it like this. Apply. I open the sprite editor, click Slice, choose Grid by Cell Size, and I set it to 64 × 64. Then Slice, and Apply. Now we have individual tiles designed to fit together. We can use them to draw any road shape we need for our game. If I expand the sprite sheet, I can see the sliced frames. Now we need to turn these frames into a kind of a paintbrush, so we can paint roads in the game world. In Unity, we can do that using a tile palette. You can open this panel by going to Window, 2D, Tile Palette. I expand this top part, and I click Create New Tile Palette. I'll call it Roads, and I click Create. It opens a window. I navigate to the Assets Art folder and select it. It creates a new file in that folder. Inside Assets Art, I right-click, choose Create Folder, and call it Tiles. With the Tile Palette window open and Roads palette selected in the drop-down, I drag and drop the Roads sprite sheet in. In the pop-up window, I go inside the Tiles folder and I select it. And that's how you create a tile palette in Unity. Now I have individual tiles. I can select any of them and use the tools in this bar to draw the game world. Next, we need a tile map to draw on. In the hierarchy, I right-click, I choose 2D object tile map rectangular. It automatically creates a grid, and I'll nest all my tile maps under it. This tile map will be called Roads. I already have a tile selected and the basic paintbrush tool active. With the Roads tile map selected here, you can see we can already paint tiles. We're using relatively small pixel art for this, so let's zoom in a bit. I select the main camera game object, and in projection, I set size to 3. Notice how it zooms in and the visible game area gets smaller. Okay, I zoom in here, like this. With Roads selected, you can see I have the basic paintbrush tool and tile selected. You can simply draw the tile like this. Then I select the upward bend and place it here. Then the tile for the road going up, and I paint it here, like this. Now the bend going to the right. Okay, this looks good. Some tiles going right. Then this tile bends the road downward. Then another tile bends it to the left. I kind of want to twist the road like this, so we can really see if our 8-directional car sprite sheet animates correctly in all possible directions. Again, I use a horizontal road piece going all the way here. Then a left turn going down, another turn going the other way, and I keep adding tiles curving my road around, making sure I ideally stay inside this white rectangle, which will be the visible game area. Finally, I paint horizontal tiles as the road goes off screen to the right. We can also create animated tiles. Unity supports auto-tiling, where we define logic and the pieces snap together automatically. But for our little project, this is more than enough. We also have other tools here, like the eraser, for example, if we want to delete some tiles. I want a green grass background. Normally, there would be a tile with only grass, but this tile map doesn't have it, so we'll handle it differently. In the hierarchy, I right-click, I choose 2D object sprite square, I call it background. Using the move tool, I move it somewhere here. Then I select the rectangle tool, which gives me 4 handles, so I can stretch and resize it however I want. I just make sure it's bigger than the visible game area. In the sprite renderer, there's a color field. I click the color picker and sample the green from the tile map. Nice. I think I'll parent it under the grid game object just to keep the hierarchy clean. I'm happy with this. I go to Assets, Prefabs, Waypoint Prefab here. In Sorting layer, I add a few layers. Background, Objects, and Foreground. The Waypoint Prefab will be on the foreground layer for now. The background image will use the background layer, with order in layer set to 0. The road tile map will also be on the background layer, but with order in layer set to 1, so it renders in front of the background image. The enemy prefab will go on the objects layer. Here we have path 1 game object, and it contains a series of waypoints. With the first waypoint selected, I can use the move tool, and I can place it in the world in a way that matches the road we just drew. Let's say I will put it here in the first turn. The next one? Actually, this one is the next one, and I move it to the next turn in the road. Next waypoint goes here. I just want to place the waypoints over the road, like this. We will create more waypoints later. This is just for testing. Let's enter play mode and see if it works. Okay, that's not bad. I exit play mode. Spawn a game object selected, and I move it here so that the enemies come into the view walking along the road. And this is how tower defense games are made. But what if I want to create a game scene with cars? Look at this pixel vehicle asset pack, it's amazing. Links to this page in the description down below. You can download it for free, and you can also give this author some tip, because they really deserve it. Or you can at least leave a comment if you want. It has 23 different types of cars, and each car with 8 color variants. It gives us each car as a standard 8-directional sprite sheet, but there's also another sprite sheet with many more angles in between, which can be used to animate the cars rotating around, like we can see here, but also in a game if you want to animate the car turning in a lot of detail. It also has directional animations where the car is bobbing around and animating while driving. There is so much of free content in this pack. There are many games that can be made with these, it's so good. I download the pack, I unzip it locally on my computer, and I pick a few cars that I like. Inside Assets Art, I create a new folder I call Cars. I will pick the 8-directional version of each car that I like, and I pick one of the available colors. I drag and drop them into this folder. You can choose different cars and different colors, as long as you choose the sprite sheet version with 8 frames, like I have here. I'm going with blue micro, brown Jeep, magenta SUV, police car, red pickup, and yellow coupe. This should give us some variety of shapes. I select all of them at the same time, and for all of them I set filter mode to point no filter, compression to none, and I want to scale them using this pixels per unit field. Usually it's best if you put here the value the assets were made for. These cars are recommended by the author as 32x32, but we also need to make sure it matches the road tiles in this case, because we are using 2 different asset packs, so I might use a different value here. Let's see. I click Apply. I select my first car, open the sprite editor. You can see Unity already auto-sliced them, so we don't really need to do anything here. I will start with the police car. I expand it to see the frames, and I will drag and drop one of these frames into the scene. Unity automatically creates a game object for it with a sprite renderer component. Sorted layer will be objects. So if I compare the car now to the size of the road, the car is too big. We can scale it in 2 ways, by using transform scale fields here, or I select all of them again, and on all my cars I set pixels per unit to a higher value, which will make them shrink. I'm saying squeeze more car pixels into a unit space in my game scene. With pixel art, I tend to use values that are multiples of 16, so let's go with 128 or maybe 160. Apply. If you are planning to use bigger vehicles from the pack, like the limo, buses, and trucks, these cars probably need to be scaled even a little bit smaller, or also we can scale them individually later using transform scale. Let's see. This is a game, the cars are slightly bigger than they should be, but I like it. Real roads in the world also don't have 90-degree turns like this. We are going for a game feel, not for realism here. At the end of the day, a lot of this is just personal taste. I'm showing you how to do things in Unity and where to control everything, and you can adjust the project however you want. I rename the car to Police. Inside Assets, Scripts, Enemy, I open the enemy script. One level up, inside the scripts folder, I create a new monobehavior script. I will call it car. I open that script in my code editor as well. I select all the code inside the enemy script, I copy it, and I paste it into the car script, replacing all the code inside. I change the class name to car. Class name should match the file name. Now we have the car script separate and we can play with it. First of all, I select the police car game object and I attach the car script as a component like this. I want the cars to move slower, so I set move speed down to 1. I will also remove this, we don't need to see it in the editor. I go to Assets Prefabs and I will actually rename this to Car. I want to have a generic car prefab, and we will swap skins of different cars on that same prefab. I drag and drop the car game object into the prefabs folder. I can delete it from the hierarchy. Same as we created a pool of reusable enemy objects, I will create a pool of cars. I reset transform, add component object pooler, car prefab into this prefab field. I move it here. Spawner selected, and we want to be spawning objects from this new car pool, like this. Now if I play, we have police cars come in. You might notice that they don't go all the way to the middle of the target waypoint. We are zoomed in, and this project is using pixel art. So let's increase accuracy by reducing the minimal distance between car and target waypoint position, here on line 29. I can close this panel, and I open the animation panel. If you don't have it open, you can find it under Window, Animation, Animation. I drag a copy of this car prefab into the scene. Inside Assets folder, I create a new folder I call Animations. With car game object selected, inside the animation window, making sure this says to begin animating car, I click Create. I navigate to Assets Animations. I create a new file, and I will name it starting with _drive_right. The name is not important, but it will make my workflow easier later if I do it like this. Okay, I adjust my workspace. With car game object selected here, with the drive right animation in this drop-down, I go to Art Cars. I expand police car sprite sheet, and I drag this frame of a car facing to the right onto the animation timeline. I click the drop-down, create new clip. In the same animations folder, I create another animation clip file I call _drive_down_right. I drag and drop this frame of a car facing down right onto the timeline. If you don't see the frame icon here, it's because car game object isn't selected. Now I see it. If I press play to test that animation, my car will swap to that frame. That works. Create new clip, drive down, and I will use this frame of the car facing down. Play the animation, yes. Create new clip, drive down left, and I use this frame. OK. Create new clip, drive left, and the frame is this one, car facing left. Create new clip, drive up left, and I use this frame, number 5. Next will be drive up, this frame, and finally we do drive up right, and I use this frame. I make sure we have all 8 directions. Inside Assets Animations, I see all 8 animation clip files and one animation controller I called car. If I open that one, we get the Animator window. I can also open it by going to Window, Animation, Animator. So the animation window is where we define individual animations. Inside the Animator window, we define how those individual animation states transition from one to another. You can see we have a little panel here, each representing one of the animation clips. I can work with them here, like this, but there is an even simpler way. we can make Unity decide automatically which one of these 8 animations to play, depending on the current horizontal and vertical speed of the car. I delete all these, and I right-click. Create state from new blend tree. We will explain what exactly a blend tree is in a minute. It will be better when you see its roots. I select this new blend tree and I rename it to drive. This will be my drive-in animation state, basically. I double-click it, which will take us one layer deeper. We are inside the drive blend tree, and I select this main block. I also rename it to drive. I want this blend tree to decide between 8 animation states automatically, depending on horizontal and vertical speed. So we will do 2D simple directional. Inside parameters, I click plus. I want float, and I call it speed x. I click plus again, and another float. I call it speed y. Here inside the blend tree, I set speed x and speed y as parameters like this. Inside the motion panel, I click plus, and I add motion field. We will have 8 animations, so I add 8 of them. From Assets Animations, I take Drive Right animation clip. I drag and drop it here. Then drive down right, then down left, left, up left, up, and finally up right to complete the circle. So this is the blend tree. This is its brain, and it will decide automatically which of these animations to play based on the values of speed x and speed y. Following a simple set of rules we'll define. To set this up, all you have to understand is that in Unity, horizontally, positive is the direction to the right and negative is to the left. Vertically, positive is up and negative is down. So with that in mind, when the horizontal speed of the car is +1 and the vertical speed is 0, we know that the car should be animating to the right. Left is negative horizontal and 0 vertical. Up is 0 horizontal and plus vertical. Down is 0 horizontal and -1 vertical. We have the main directions, now the in-between steps. Driving down right is when we move positively along the horizontal axis and negatively along the vertical axis. These visuals are even showing us and confirming. Yes, this is the down right direction. The way blend trees work, it's better if these diagonal steps are 0.5, so they're closer and trigger when they should. Don't worry about this too much at this point, it'll make more sense in a minute. Down left direction is negative horizontally and negative vertically. Up left is negative horizontally and positive vertically. And finally, drive up right is positive horizontally and positive vertically. This little visual here helps us to see at a glance that we're choosing the right values as well. I can see I made a small mistake here. This value should be coming from the speed x parameter. Yes, now this column will be connected to the horizontal speed, and this column is representing vertical speed. This is the main brain of the blend tree. Based on the values of speed x and speed y, it will automatically decide which directional animation to play, based on the set of rules we just defined. You can see as the values change, the distance to each of these points changes, and that's how the decision is made. If I have my car selected here, and this blend tree selected, I'll also see a little preview of the car down here, and it will show me the animation frame as I change speed x and speed y. If you play with these sliders while watching this visual and the car animation here, it should become pretty clear what exactly is happening. Blend trees allow us to smoothly switch between multiple animations based on a set of rules we define. I really like using this. I think it's a very clean way to achieve multi-directional animations in Unity. Now all we have to do is somehow access this speed x and speed y parameters on the animator component and feed them the directional values as the cars are moving along the path. And this blend tree logic will handle the rest. I define a private variable, type is animator, and I call it, for example, animator. Inside awake, I set animator to get component animator. We are trying to find the animator component on the game object we attached this car script to. Once we have it, this is the component we can use to access its speed X and speed Y parameters. And if we connect these to the car's direction of motion, it will automatically play the appropriate animations. When I created them, I set them to be floats here. So as the update method runs over and over, I will do it exactly at this point after we calculated the relative distance. I take the animator component, I call the built-in setFloat method. We call that float parameter speedx, and I give it some value. I will also do the same thing for speed y. I will pass it +1 and -1 just as a test. So based on the rules here, we will get drive down right, because this combination of values is the closest to what I passed to it. We have one car in the scene, but we are spawning more, and those are from a prefab. I made some changes to this one copy, but not to the base prefab, so that's why we're getting an error. So with the car selected here, it's a single copy of a prefab. I go to Overrides. I added the animator component only on this copy. I want to put that on the base prefab so that all the copies get it. I see the changes here, and I click Apply All. Now even the base prefab will get the animator component. So when I play, even the cars we spawn will be working as intended. We don't really want to pass it hard-coded values of +1 and -1 here. We want to pass it the real-time values that represent which direction the car is moving as the game runs. We are currently using move speed, which represents both vertical and horizontal movement, but I need to somehow separate the horizontal and vertical components so that I can pass them as horizontal and vertical speed values to the animator here, so the animator can decide which animation state to play. There are so many ways to do this, and multiple values can be used, so this is really just one of the ways. Let's just do it, and then we will explain. I will remove .magnitude here, which is converting these vector3 values into a simple float. And that way I need this relative distance to be in vector3 format. That way we are still keeping its horizontal and vertical components separated. Instead, I'll use .magnitude here, where we need it. Here we are checking if the enemy is close enough to its target waypoint. And here I can pass the horizontal component of relative distance as speed x and the vertical component as speed y, because relative distance is in vector3 format. It has x, y, and z components. I save that and I play. The car is turning. We are rotating it based on the relative distance, based on where the car is in relation to the waypoint it's trying to move towards. We got it almost right, it's just flipped in the opposite direction. I could fix that by flipping these values from positive to negative. I could also adjust the relative distance calculation, but to keep this as simple as possible, I'll simply flip it here. Multiply this and this by -1, which means if it's positive, it will be negative, and if it's negative, it will be positive. We are saying check the relative distance between the position of this car and the target waypoint and pass that horizontal distance as speed x to the blend tree and the vertical distance as speed y. I could clamp these relative distance values, but let's not do unnecessary operations if Unity can work with the values as they are now. And this is how you use blend trees to create 8-directional animations in Unity. We have very simple animations here, but the same technique can be used for animations of any complexity. The cars are turning 90 degrees instantly because of the shape of the roads, so we don't get to see the diagonal frames. I could, for example, use 2 waypoints per turn to show that diagonal frame. For now, I will leave only one waypoint and I delete the rest. I copy and paste that same waypoint 5, 10, 15 times. With the path1 GameObject selected, in the waypoints array, I set the size to 1. To add all of them at the same time, I can lock the inspector so it stays on this path 1 object. I left-click the first waypoint, I shift-click the last one to select all of them, and then I drag and drop them over the name of the array, like this. And it will add them in that order. Now I select waypoint 1, use the Move tool, and move it here. Waypoint 0 will be here. I want to do 2 waypoints per turn in the road. Waypoint 2, the third waypoint, will go up here. They're too big for this pixel art project. I go to Assets, Prefabs, select the waypoint prefab, unlock the inspector, and set the scale to 0.3, 0.3. That's better. Waypoint 3 goes here. Waypoint 4 here. Waypoint 5 somewhere around here. Notice I'm trying to make the 2 waypoints at each corner sit as close to a 45-degree angle as possible to match how the diagonally facing sprite looks. If we get the angle between waypoints right, it will look good when the cars turn. We can always adjust these later, once we have some animation along the path. Waypoint 6 goes here. Waypoint 7 here again, roughly at 45-degree angle. Waypoints 8 and 9 in this corner. 10 and 11 here. 12 and 13 go in this corner. 14 and 15 here. I can already see I'll need more. If you're coding along, you can do any road shape you want. You don't have to follow exactly what I'm doing here. I copy waypoint 15 and I paste it several times to get 16, 17, 18, 19 and 20. With path 1 selected, I lock the inspector again. I select the new waypoints I added and drag them into the waypoints array, like this. Great. Waypoint 16 selected, I use the Move tool to place it here. 17 goes here. 18 and 19 in this corner. Waypoint 20 takes the cars off screen, like this. Let's move the car here. I hit play. The object spawner is creating more cars for us. Notice that when they turn, they now show the diagonal frames. If the turn doesn't feel right, maybe it looks like the car is sliding around, try adjusting the angle between the 2 waypoints in the corner closer to 45 degrees. This is pretty good. I unlock the inspector. With the waypoint prefab selected, I set the sorting layer to background and the order in layer to -1 to hide the waypoints. We can make the game world nicer with some environmental art assets. How about this free pixel art tree pack? Link in the description below. It has 15 unique trees. I download it, I unpack it, and I pick some trees I like. In Assets Art, I create a folder called Trees. I drag and drop the trees I picked into it. You can choose as many as you want and pick any shape or color you like. With all the tree images selected, I set filter mode to point no filter, compression to none, and pixels per unit to 64. I click Apply. I select my first tree and I drag it into the game scene. I can't do all of them at once, or Unity will think I'm trying to create an animation. I have to do them one by one. With all of the trees selected, I set their sorting layer to foreground. These trees will appear in front of the roads and cars. If you wanted to make the car appear behind and in front of the trees as it goes around, in a 2D game like this, you would use transparency sort axis technique and adjust objects' pivot points. I do that in other classes, but this project doesn't need it at this stage. I spread my trees around to create a nicer pixel art countryside scene. I right-click in the empty space in the hierarchy, I choose Create Empty, and name it Trees. Then I nest all of the tree objects under it to keep the hierarchy clean and organized. Now, if we play, we have a lot of police cars driving through a nice pixel art environment. They spawn at 1-second intervals. Maybe I want to randomize the interval to make it feel more natural. I exit play mode, go to the object spawner, and open the spawner script. Initially, the spawn interval is set to 1 second. Every time we reset the spawn timer to 0 and spawn a new enemy, in this case cars, we now set the spawn interval to a random value between 0.5 and 1.5 seconds. Save and play. Cars start spawning, and they're no longer evenly spaced. We get random spawn intervals. That was easy. I hope you're getting some game ideas, because we can do so many different things with this. Come on, indie game developers, show me how creative you are. We have a big art asset pack full of different cars. So far, we've only used police cars. So, how do we create randomized skins and spawn different types of cars into this countryside traffic jam? I could just follow the same process and create a separate prefab for each car type. But all of these have 8-directional sprite sheets, and we need to set up all of the animator rules with blend trees, 8 directions, and speed x, speed y values for each car individually. We would have to do that for every type of a car. As usual, there are better ways to do this and save ourselves some time. In this case, the animator setup is the most time-consuming part, so let's focus on that and streamline it. Inside Assets Art Cars, I have my blue Micro, brown Jeep, and so on. You can pick any car you want, just make sure you pick the sprite sheet with 8 frames, each facing in a different direction. They all have the sprite sheet with different tile names, but the logic is the same, 8 frames, each facing one direction. If that logic is the same, we can reuse the same animator and blend tree we already created. We don't have to set it up from scratch for each car. Let's use the blue Micro as an example. I drag and drop one of its frames into the scene. Sorting layer is set to Objects. I rename it to Micro. I open the animation window. With the Micro game object selected in the hierarchy, I click Create. Inside Assets Animations, I'll create 8 directional animations for Micro. This is basically the only part we'll need to do separately for each car. So let's do these from top to bottom. I select Drive Down, add Micro in front of it, and save it as a new animation clip. I copy the word Micro so I don't have to type it again. Save that. With Micro still selected, for Micro Drive Down, I drag and drop the frame of the car facing down into the timeline. If I hit play, I get that frame animating. Good. Next, I create a new clip, Drive Down Left, paste Micro in front, and save. Drag and drop the correct frame onto the timeline. Play to test. Looks good. Create a new clip, Micro Drive Down Right. Save that. Drop in the down right frame. Create new clip, Micro Drive Left. Be careful not to override the original 8-directional states, that would be annoying to fix. Maybe even back up these files first. If you do override them by accident, there's also a GitHub repo linked below where you can grab this Unity project. Drive Left goes with this frame. OK. Create new clip, Micro Drive Right. Save it. Drop in the right facing frame. Create new clip, Micro Drive Up. Use the up facing frame. Test it. Yes. Create new clip, Micro Drive Up Left. That's this frame. It works. Finally, create new clip, Micro Drive Up Right. Save that. Use the up right frame. Great. In the Animator window, we now have 8 new animation states. This is where we normally delete them and recreate the blend tree, but we don't need to do that here. We can just reuse the animator from the car we already set up earlier. This will work because all the cars are the same in terms of the animator. They all have 8 directional drive-in animations. Inside Assets Animations, we now have the 8 animation clips we just made. Unity also automatically created an Animator controller. We can see it here. In the Animator, we define how these states transition between one and another. Now I want to override this microcontroller with the existing car controller, the one we already have with that complicated blend tree setup. So I right-click in the project window and choose Create, Animation, Animator Override Controller. I call it Micro Override. With Micro Override selected, I go to the inspector and I set the base controller to the original car controller, the one we set up earlier. Now it gives me 8 fields, one for each animation state, where we can define which micro animation will override the original. The transitions and logic from the car controller will still apply. Drive down is micro drive down. Drive down left is micro drive down left. Drive down right is micro drive down right. Drive left, micro drive left. Micro drive right. Micro drive up. Micro drive up left. Micro drive up right. This is super useful, especially if your car controller is complex with lots of transitions and state relationships. What we just did can save you a lot of time. Finally, I want to have only one car prefab. And as I'm spawning cars, I want to automatically assign it one of these Animator Override Controllers we just created. That way, each car gets a random skin. I'll create a private variable visible in the Unity editor. It will hold Animator Override Controllers, like the one we just made for Microcar. It needs to be an array, since I want to have multiple skins, and I'll call that array, for example, skins. The onEnable function will run every time we set this car to active, so every time we pull it from the object pool and spawn it in the game. When that happens, I take its animator component and set its runtime animator controller to one of the skins from the array. For example, I can assign skins 0, but of course we want it to be random. I don't know how many skins we'll have in the array, but we need at least one for this code to work. I'll choose a random index using random range between 0 and skins.length. That gives us a random index from 0 to the number of elements in the array. Save that. In Unity, I can delete this copy of the car from the scene as long as I've applied all the changes to the base prefab. I can tell that by checking the override section. If it's empty, then my changes have been applied. Now I delete it. On the main car prefab, I'll see the skins array we just defined. I lock the inspector, go to the animations folder, I drag the micro override file into the skins array. Now if I hit play, since we only have one skin, all of the cars should appear as blue micros. As they drive around, I can see their directional animations working correctly. They are switching based on movement direction. Even though I didn't set up a new blend tree specifically for this car, we are just reusing the logic from the original blend tree we set up earlier in the class. This is how you can save time when you want to use multiple skins for objects with identical animation setups. All of the cars have the same set of animations, and that's why we can use this technique. Inside the prefabs folder, I create a new folder called Other Cars. I don't really need this micro game object in the scene anymore, but just in case, I'll turn it into a prefab and I'll leave it in this folder. We're not using that object directly. All the cars in the game are instances of the main car prefab, and we're just swapping its skins. And here's a challenge for you. Can you give this car prefab another skin? If you can, pause the video and try it now. If you want a bit more help, let's add another skin together using the same technique. Inside Art Cars, I choose another sprite sheet with 8 frames. I'll go with the brown Jeep this time, but you can use any car you want. I drag and drop the first frame into the scene. I unlock the inspector and rename the object to Jeep. We won't actually use this game object for anything in the game. We're just going to build the animations on it and then discard it. We could do this whole step without this game object, but it's easier for me to work with it like this. I set the sorting layer to objects. With Jeep selected, I open the animation panel and click Create. Inside the Assets Animations folder, I create a new animation clip called Jeep Drive Down. I drag and drop the down-facing frame onto the timeline. Create new clip. Jeep Drive Down Left. That's this frame. Create new clip. Jeep Drive Down Right. I drop in the correct frame. Create new clip. Drive Left. I drop in the correct frame. Create new clip. Jeep Drive Right. That's the first frame. Then Jeep Drive Up. Jeep Drive Up Left. And finally, Jeep Drive Up Right. I drop in the correct frame. Now I check that I have all 8 animations in the dropdown. Inside Assets Animations folder, I right-click in some empty space and I go to Create, Animation, Animator Override Controller. I name it Jeep Override. With that file selected, I go to the inspector, and for the controller reference, I select the base car controller, the one we created earlier with the complicated blend tree. Now I connect each Jeep animation to the correct state. Drive down left, drive down right, drive left, drive right, Jeep drive up, Jeep drive up left, Jeep drive up right. I no longer need the Jeep game object in the scene, so I turn it into a prefab and move it into prefab's other cars. Then delete it from the scene. Now, on the main car prefab, we have the skins array. I lock the inspector. We go to the Assets Animations folder and drag and drop Jeep Override into the array. Now the car prefab will randomly get either a Jeep skin or a micro skin, because we are randomly selecting from the skins array on line 24. I hit play and wait a bit. And yes, we now have another skin for our 8-directional animated car. You might have a question at this point. We also created the police car all the way in the beginning. How do we add that into the mix, while still following the same structure we've been using? We can actually do that very quickly. Inside Assets Animations, I right-click and go to Create, Animation, Animator Override Controller. I name it Police Override. I unlock the inspector, select it, and set the animator controller to the base car controller again, the one with the blend tree set up. Now I start filling out the animation fields. Drive down left, and so on, making sure each clip is correctly matched. Inside Assets Prefabs, I select the car prefab and lock the inspector. Back in the Animations folder, I drag and drop Police Override into the Skins array. Now, the car prefab can randomly take on the appearance of a micro, Jeep, or police car. You might see a warning message in the console. You can safely ignore it. If we hit play, everything works as expected. We could also turn this into a tower defense game, or maybe a traffic control puzzle game. I've got a few ideas. If you like this direction, I'll continue building this project out further. As always, I'll decide what to work on next based on your comments. Big like if you found this helpful. Full source code is available on GitHub, linked down below. See ya!